Okay, so here's some example from you.
Yeah.
So, what's wrong with this?
It doesn't work. I mean, it's wrong. I don't. That's what my question was really.
Okay, so first problem. Random is not defined.
Oh right, import. It. Yeah. Okay.
Next problem. Name error, name is not defined. We have a line here, line 23. I'll turn off this relative number thing. Right here. So yeah, clearly name is not defined, right?
It's, yeah, I need to put it above print, right?
In what sense?
Name and kind, because they're both not defined.
No, they don't need, well, I mean, I guess it depends on what you want to do. You want this to be like the dog's name, right? Associated with the dog object?
Yeah, which you get in this other function, the first name your Doge.
So you will assign it here. So yeah, so this is all broken, but we'll deal with this one first. So name, just name alone, is undefined. There is nothing in this that defines the word name, and there's nothing out here anywhere that defines the word name, and so that's why it's exploding.
Yeah.
There is a name defined on the dog object, which is called self now. You could do a number of things to access it. You could just stick it here, for example. So now we're saying, okay, name is actually on self. So first go to self, and then go to name.
And then where does it go?
And well, at this point, it will find the value associated with name.
Which is where?
I mean, it may or may not exist, but we know it exists because you wrote this class so that it will be defined.
As Doge?
Right.
But I don't want it to be Doge.
You could possibly change it.
I want it to be this line.
Why does this keep getting set?
14?
Yeah, so, I mean, in theory, we'll get there. First, let's just deal with this broken.
Okay.
We want it to run first, and then we can talk about whether or not it's correct. Okay, so that's one way to do this. You could, of course, give it a name out here first, and then, oops. And then
type name there.
Right, leave it how you had it. And we have to do the same for kind, because that's going to be the next problem. So we've done this now, and now we should, right. So Pete the Labrador Retriever, and yet we still print Doge and Mutt.
Yeah.
And if you saw up here, in our initializer, we assigned self.name, so the dog object's name attribute is assigned the value Doge.
Yeah.
And the dog object's kind attribute is assigned the value Mutt. And you'll notice at no point in the rest of the program do we ever change that. And that is why here it's still the same.
Isn't it, though?
No.
That's not changing it?
Where do you see it
line
changing
14, it? Well,
here.
Your lines are messed up again. But.
This is really annoying. Oops. So here, you mean?
Yeah.
No. This is just name. This is not attached to anything.
Oh. Okay.
The same way we could have done, like in our previous example.
What if I called it,
sorry.
What if I wrote...
In our previous example, just want to talk about this real quick. So in our previous example, we had pause up here as a default thing. But like I said, this is just pause. And this is just pause down here. And this is not an attribute. This is just a value.
Okay.
Or a variable, just like as if we had done like zoo equals 4 rather.
Yeah.
This is clearly not attached to the dog.
Yeah.
Dog has no zoo attribute. So that's what's happened up here. And as of right here, it's still not attached. And then over here, we finally say, hey, we're going to attach this to an attribute, which coincidentally is also called pause. But it didn't have to be that way. We could have had a different name here, right?
Mm.
And this function is exactly the same as the previous one. Okay. So here we're assigning self.name. Here we're doing self.kind. Down here you're just assigning name, and it's totally independent of anything else. Even if you had, so never mind, you do have self.name, but it doesn't interfere with that because we're not referring to that one.
Should I write self.name there instead?
Right, so if you want to refer to the name which is attached to self, then you have to tell it that.
Okay.
And that's why every function gives you a copy of, or a reference to the self object so that you can do this.
Okay.
If you didn't have this, then there would be no way to do this because self would not be defined right now.
Yeah.
And so now you can never access this thing.
Self is an object.
Self is the instance of the dog class that you're working with. So it's an object.
Yeah.
It's an object in the informal sense, and it is also formally an instance of object, the class.
Okay.
Yeah, so you were pointing to something.
You have to change it over there too.
Right, so now this name is undefined, right? Because here we're using the name that's on self, and here we're not, and so this one doesn't actually exist. So we need this if we want to.
And then the same with kind.
And the same thing will have to happen down here as well.
And now we can try it.
And now, do you think it's going to work yet?
No.
Why?
Wait, yes.
Why?
Because I think it will.
Right, but why?
Looks good. Everything looks right, I think. For now. I don't know.
Okay.
Let's just try it.
Sure. Now I also think it will work because here we're assigning to self.name and self.kind, and then later we're grabbing values from those, and so unless something magic happens, Shadow the poodle, and your dog's name is Shadow, and he's a poodle. Yes. Good to go. So there you go. Classes. Basically, this is how it works.
Basic.
I mean, this is how it works, right?
Yeah.
So the difference is like it's good practice to allow people to change the defaults most of the time. That's what you want. So then you could choose a name for your dog. You may decide you want to override it later. So like name equals barf. And let's not rename the dog. And so he's a schnoodle dachshund, and
Why doesn't
the
it
name
say
is
barf?
Doge. That's a great question. Oh, why? You tell me.
Do you have to have self.doge? No.
Self.doge. No.
Um.
So what happens here? Ignore the rest of the function right now. What happens up here?
You're saying name is doge.
True, except we're not actually, because it's a keyword argument, right? And we're overriding it. Whoops.
Oh.
So in actuality,
Wait, what?
so let me close this thing down here. So you see down there on what says 19 right now,
Yeah.
19 below the cursor, you can see that we're calling the dog constructor, and we're telling it, for this particular invocation, name is barf.
Yeah.
This says, like, if they don't say what name is, then it's doge.
Yeah.
But we do say what name is,
Yeah.
and it's barf. So for this particular call, it will treat it as if this said name equals barf up here.
Yeah.
And so that's what's happening there. So anyway, go ahead. So after this line, name equals barf.
But then you don't ever reference barf again?
What do you mean?
Well, self.name, would that change to barf instead of doge?
I don't.
Right there where you are?
You want this to say barf?
No, if you give name equals barf, is that going to be barf down there now?
Up here?
No, where you were.
No, I'm saying if you give name equals barf, like here, like we did,
Yeah.
you're asking if this string will change to barf?
Yeah.
No, this is a string. This is a literal string. The same way, like the number 7 is always the number 7.
Okay. Yeah.
This is always going to say doge forever and ever.
Okay.
So,
Yeah. What's the question?
question is, why doesn't this work?
Do you only have to give barf and not name equals barf? Line 19.
No. So line 19 is right.
Oh.
We're saying the keyword argument name is going to have the value barf. That's it. Up here, we're assigning the name, to the value barf because we overrode this one,
Yeah.
and then we never use it again.
That's what I was saying.
Oh,
Well, not really.
That's
I
not
was
that,
saying
that's not at all what you were
Doge
saying.
Changed to barf, but I was thinking about it. That should be barf.
No,
Well, it should become barf.
it
You
will
specify
have
barf.
the value barf, but it will not literally be barf. What will it be?
It'll be name.
Yes. And down here we'll need kind as well. So now remember, this is just assigning.
Oh, this is so that you can give the name and the kind.
Right, but I mean, if you didn't do this, you're saying.
Then those are the default values.
Well, these are just literal values. You're saying like self.name equals Doge, no matter what.
Yeah.
I don't care what anybody
Okay.
says.
Yes.
So
Let's do it.
what on earth is going on? There we go.
Name and kind.
Right.
And print. Or
And
run.
we don't have to print anything. Right. Yes. Buffer not found. What happened? Damn it.
Doge is a Labrador Retriever.
So his name is Barf, and he's a Labrador Retriever.
Okay, it works. Nice.
It does, yes. Now he's a Schnoodle Dachshund. And if we rename him, then when we hit this line, we're going to overwrite our original value, and he'll have some new name that I didn't pick. Like Pete.
Okay. And right now, the kind, we haven't specified it. So it's just, it's not mutt anymore, but it says mutt up there. Line,
True.
Whatever.
So as of right here,
Oh, but we're changing it with the function.
right.
Okay.
So if we don't do
if we
this,
took that away, then it would be mutt. Right.
Yes.
Okay. I'm getting it.
Yeah. So that's how this works, basically.
I'll have to make some more
Yeah.
examples.
It's definitely a good. Yeah. So the way to get the intuition about this is just to do a bunch of them, and maybe come up with some cool ways that they can interact. Like if we make let's make a class like cat. I'm gonna come up with some crazy example here, just off the top of my head. So let's say we don't care anything about this cat. Let's just use it as an object. Right. So here, let's say let's also make people. So let's say if our doggy meets a person, he barks, and if he meets a cat, he goes crazy.
That's going crazy.
Yes, he's really out there. So now my pet, me, and I'll be the cat. You can be the person. So my pet dot greet you, and then my pet dot greet me. And so now you can tell me what the output will be for this.
It'll be woof and then woof woof. Right?
Yes. So first, we'll go here.
Yeah.
And then it'll see the other guy's a person, and so we woof, and then the next time it'll be the other guy's a cat, and so we lose our mind.
Okay.
And when we run it, we get a syntax error. Is instance other cat woof. What?
What happened?
I don't know. Interesting. I don't know Python, I guess. This totally looks... Oh, of course. It's another conditional, right? So it has to be elif.
Oh.
Else is for things like you had no condition and like...
Okay.
And say he meets like an empty list. Whatever that means.
Okay.
So he meets a person and he barks and he meets a cat and then he goes totally crazy. And then he meets the empty list and he declares that this makes no sense.
Alright.
And, you know, I think then that's how it goes. And like, for example, let's say our cat had some attributes. So the cat has like fur, which is soft. And so when we lose our mind, right? Is this making sense? So the cat has an attribute soft, or sorry, an attribute fur type, which has the value soft.
Why did you type other?
Because up here, that's the name of the cat attribute.
Oh.
So here, when we call the greet function, the first argument is the instance on the object on which we're calling the function. So myPet.greet, self will be equal to myPet.
Okay.
The second argument, and all other arguments, are the arguments that you pass to that function. So down on 22, down there, we're passing in you, and so other will be you.
Okay.
And later, other will be the cat, which is me. And so down here, because of this, basically, other is a cat object. If other was not a cat object, we wouldn't be down here, because this would have failed. And so on cat objects, we have a fur type, and we can grab that attribute, just like any other. And so now, when we do this, alright, well you see here. So woof, woof. So here we're losing our mind, these two lines. So he woof woofs, and then later he says, wow, this is some very soft fur. And then the empty list he still doesn't recognize. Yeah, so that's how it goes.
Okay.